Good day, everyone. Good day, everyone. So, my name is Mambo Sef Eli Tutor. So, I hope you have been able to watch the previous video we did on polynomial revised edition. So, today we are going to be considering theory of set, like set theory. But before I start with the introduction of set, let me make a little proof. So, just hold this in your right hand. So, I'm going to be proving the De Morgan's law. So, alright, in our secondary school, we are all familiar with the word intersection. Something like this. We are all familiar with the symbol union. Something like this. We are all familiar with what else? Subsets. We are all familiar with super subset. We are also familiar with super set. Subset and the superset. So we are all familiar with all these symbols. Alright, so that's not what we are doing this evening. So this evening I'm going to be proving the De Morgan's law. So now, in De Morgan's law, it is said that whenever you have something like, for instance, you are having A intersection B, the rule of De Morgan's, let me just tell you, if you are having into bracket A intersection B prime, so the expression is going to give you A prime union B prime. The same thing if you are having A union B all carrying prime, so complement of A union B. So the expression for this one is going to be complement of A intersection complement of what? Complement of B. So that's one thing you have to understand. Okay, all right. So this thing is something you really need to get right. Alright. So today we are going to be proving the De Morgan's law. Alright, so we want to prove that into complement of A union B, is it true that it is going to give us complement of A intersection, complement of B, and more so, complement of A intersection B? Is it going to truly give us complement of A union, complement of B? So that's what we want to prove. So it starts this way. So suppose element of X belongs to, let this place be our left hand side. So I would have write this one here, you get. So let this be our left hand side. Like I mean what you have here. Don't forget there's prime here. So let what you have here be your left hand side, and what you have here be your right hand side. So I'm going to be using because most cases we use what we have in the left hand side to make our proof. Okay, if you remember vividly during trigonometry. So now we are going to use this to prove whether truly is going to give us this. Alright, suppose element of X belongs to what we have here. So what do we have here? We have into brackets A union B complement, right? So if X belongs to A union B, it means that X belongs to A union B. If X belongs to this, it means X does not belong to A union B. That's the meaning. Are you with me, guys? Remember I said if X belongs to into bracket A union B complement, so it suffixes that X does not belong to A union B. That's what it means. So if I'm proceeding further, so let me break it down so you can understand. So for me to say that X does not belong to into bracket A union B, so it's so saying that X does not belong to what? Does not belong to A, and element of X does not belong to B. I'm crossing it because it does not belong to. So it's still the same as saying that X is not an element of B. Alright. So if this is not an element of B, of this, it means that S should be an element of A prime. For the fact that S is not an element of A, definitely S should be an element of A prime. And the same thing applicable to this, that X is an element of what? B prime. So it's still the same thing as complement. Hope you are getting the process. It's not hard. Remember how we started. I said suppose S is a member of into bracket A union B all carrying complement. So if this one is a member of this one that is carrying complement, by the time you remove this complement away, it means that X is not a member of the one that is not carrying the complement. It's just a word and opposite. Alright, So splitting this process, so we have it this way, then it's still this means, so if you look at this way, I said if x is not an element of A, definitely s is an element of A prime. If s is not an element of B, it means that x is an element of B prime. Alright, so now we can now conclude the process saying that since s is an element of A prime and s is an element of B prime, x is common to both sides. So therefore we say that x is an element of what? Is an element of A union, let me say s is an element of A prime intersection B prime. That's all. So it means that x is an element of A prime intersection B prime. So we have satisfied this process. So this is what we are having at the end of the day. So it is proved. So let us do the same thing for the second case. So we are going to repeat the same process for this. Do you get that now? Let's go there. So this one should be very easy for you to cope with. So suppose that for the second part, suppose that x is a member of, so what do we have here? The same thing, the same process we did here. We are going to repeat the same thing here. So suppose that x is an element of, into bracket, A intersection of B, then all carrying complement. So if x is a member of complement A intersection B, so it suffix that x is not an element of A intersection B. Try to get the point. This place I said, if x, suppose x is an element of complement of A union B, definitely x is not an element, is not a member, or is not an element of A union B. So it is still the same thing. It's repeating itself here. Try to get it right. So if I will break this one now, it means that x is not an element of A, or x is not an element of B. X is not a member of A, or x is not a member of what? Of B. So if x is not a member of A, definitely it suffices that s is a member of A prime, or s is a member of what? Is a member of B prime. It's a two different things. So try to get the point. No stress. So putting this together, so it suffices that s is a member of what? A prime union what? Union B prime. So this is proved. Okay, so I can reduce it. So don't forget, in your probability is the shortcut saying that all represents what? Plus. Do you get that? Which you can also call your union, and your and represents what? Times, which you can also call your intersection. It's a short form, so if you reference to probability, don't forget. So it is derived from that your all represents addition and your and represents your cross product. So now, therefore, or let me just say hence, by the Morgan's rule, by the Morgan's law, A union B complement is equals to A prime intersection B prime. And if you have A intersection B on carrying prime, the expression is going to give you A prime union B prime. Proved. It is very, very simple. So take a look at it very well. It is something that is not going to take you time. Just take your time and listen to my explanation one after the other. Pick out a point and you get it right. So I hope you shouldn't find anything difficult by the time you have it in your exams. God bless you. Don't forget to subscribe on this channel, because I'm going to be posting everything back to back. Set theory explicitly. I'm going to be breaking it down.